Hey everyone, today we are going to learn about player and how the player class is going to be running. What we did last episode was load in a tile map, and inside our source folders we have got our loader class, and this just loads a tile map. We will eventually just load a single image, but this is just loading images inside an image, as we did last episode. And when we run, it takes the single image and renders it on the screen. Quite small. So let's quickly do a couple of changes just to make it a bit more easier to use. So in here, this is one keyword argument. Let's have another keyword argument, and this will be called scale, and that is equal to a tuple. This is what we're going to change to the new scale. So the new scale, I think in settings we've already gave it. No, not yet. Okay, really confusing, but for now remember how we did in the first episode. This was our global variables. Let's make another global variable called tile size, and if you don't know, it's the size of what a tile will be. And let's just set it to 64. You can set it to 64, 32, any number, to be fair. It's just what one tile on the X and Y would equal, because right now a tile is just going to be a square. So when we load, let's set the default values to tile size and tile size. And when we're appending this, this is the cut image. So this is the cut image from the base image, and then we're adding it to the list. So let's just, before we add it, we need to change it. So let's just go img equals this, and that is the cut image. And then we're going to modify this. So img equals pygame.transform.scale, and we're going to scale the image, the surface, as it says, and then we're going to give it a size, and that's a tuple. It should say, it doesn't really say, it is a x and y in a tuple. Oh, there it is, tuple. So here we're just gonna not even have to do anything, we just give it scale, and then we will just give it image. So when we run this, now this is bigger because we've changed the scale of it. It is now changed the scale of the image. So that's one. Number two, in settings, instead of every single time we type this, we could just say where the image folder is. So the image is our assets and images, so we won't have to write this. So if we just copy this out, and that as well, come here and just give image path. The image path is equal to os.path.join. Now this is much better when we're using other operating systems like Mac and Linux, because this automatically finds how we're going to go in a folder. With Windows we use this, but for Mac it's probably another way. So we're just going to os.path.join, and we're going to join the assets. This is a string, assets, and then we're going to go inside that, and we're going to get images, and then that's that. So we're just going to do that for now. When we're in world, instead of doing this, we need to use os.path.join, and then the image path that we just made, and we also need to give it our other positions. So main character, copy this, and inside main character we are getting Ninja Frog, so we copy Ninja Frog, and this actually needs to be, we actually need to make this in the function, and then inside image frog we will just use idle. So copy this and then use that just for future self, but it does the same thing, so you could just keep it originally. So right now we have done some really simple edits to the code. What we are going to do now is make something more interesting, the entity class. So the entity class is going to be a bit complicated to try to explain, but all you need to know is a enemy, a player, maybe a trap as well. They are all going to be connected to an entity class. So this will have inside it animations, collisions, movements, and basic variables. So if we would just make the player have all of these, how about we make all of these variables accessible to all these other classes? So that's how we use parent classes and child classes, and it gets kind of confusing after that, but all you need to know is the entity is going to be the parent class, and the player, the enemies, the tiles, they're all going to be children of the entity class. So let's actually program this to try and visualize it. So in the source code we are going to add a new folder called entities, and this is where we will have players, enemies, all of that. And in here we'll just have a base class called entity, and try not to capitalize. I'm too used to Java, but the way we do it in Python, we don't capitalize file names, we only capitalize classes. So as we know, what we normally do is from source.engine.settings, it was settings, import everything. Let's make a class for entity, and this actually is going to be a child class of the pygame sprite. So pygame.sprite.sprite. Now this, why we're making it a child of sprite is because sprites is how we can render multiple images to the screen in one function call. Otherwise we'd have to use multiple functions, multiple lines, and it'd just get really messy, our code. So this is to organize it, and also it's optimized a bit better than how someone else might program it. So we need a constructor, and in the constructor we need a position, and that's going to be a tuple. And we will also have maybe frames. So frames would be a dictionary of all of the images and the animation types there are. And then we need a group, so a variable to group it all in and then render all of the images to that group, if I can spell group. Now this sprite already has a initialize function in it, so we're just going to call that, and that's just super, and then super init to initialize the parent class, and that argument needs a group, and we just pass in the group. We also do need an image and a rectangle, or the rect, and that's to show position, width and height. So what we're going to do here is set a couple attributes before we do the images. So self.frames equals frames, self.index equals 0. Index is going to be the animation timer type thing. Self.status, status is going to be our animation type, so it could be idle, walking. We're right now just going to do idle, and I think that's everything. So let's make the image. You have to copy this word for word. These you don't have to, but this you have to copy. So self.image, and it's a built-in variable. You need to do this. It can't be img, it has to be image, equals pg.surface, and let's just give it a 100 by 100, so it's going to be a square image. And then another one you need to copy this is self.rect equals self.image, and then we get the rectangle from the image, and this requires a position. So we're going to say the center position is going to be the pos that we give him up here. So we give it position, an array, and a dictionary of frames, and a group. So in world, let's quickly get rid of this and get rid of that and pass here so it's not going to crash. Let's quickly, from source, entities and entity, let's just import entity for now. Let's make a group. So visible sprites is going to be all of the groups that are going to be visible to the player. So self.visible equals pygame.sprite.group. So it's in the sprite folder. I think it's a folder or a file, but you don't need to worry about it. All you need to know is it's in pygame sprite and group, and it's a class, so you need to call it. And then we're gonna do self.entity, and then we're going to give it the entity class, and we gave it some arguments. So the position will be, let's do 100 by 100, so it's going to be like a little bit from the top and left. The frames is going to be just an empty dictionary for now, and the group is going to be self.visible sprites. If we run it, nothing will happen, but it's not giving us an error, so it's good. Why nothing's happening or rendering, even though we've got an image and a position, is because we're not rendering everything in the group. We're just saying this is a group and we're adding this to the group. So right now we're going to render it, self.visible_sprites. And then it's not render, it's draw. And then we're going to draw it to the surface. So the surface is the window right now. So it's just self.win. And then we update it the same way, self.visible_sprites.update, and we'll give it a argument of delta time, even though delta time is nothing now. And when we run this, we finally get our first entity on the screen. Okay, so we've got the entity up and running, but we want a player. So let's go in entities folder, and we're going to make a player class this time. And we could basically just copy the import and class player, and then this takes the this needs another class. So from source entities and the entity class, we want to take all of the variables and functions from the entity class. Let's initialize the player with a position, frames, and group. And all we need to do is call the initialize function for this, as we did last time, and we just give it the exact same arguments, so frames and the group. So now we can make custom functions just for the player, but we can also take the functions from entities as well. Don't need to do anything here, this is just going to basically do the same thing, but instead of calling entities, we're going to go player, and we're calling player class. And when we run player, boom, it's doing the exact same thing, but it can use custom functions just for the player, but it can also take all of our entity functions, and this is what we're going to need. So let's quickly add another variable called anim speed, and that means animation speed. I like it to be 7. So right now we have got the player, but it's just a square. It's nothing, not even an image. So let's quickly load up all of the Ninja Frog sprites. So let's make a new function called load assets, and let's give it a self.assets is a dictionary, and player is a key, and that's going to have another dictionary inside it. So it's a dictionary, it's got a key, and that key's value is a dictionary. And let's go idle. So idle will be this one here. So it's actually facing the right, but we won't do anything about that now. We will just say it's idle animation. So what we need to do, we need to load tile map and get os.path.join, and we need to get then the image path and the same thing as we've done last time. So now that we've got all of our images loaded in, or images for the idle animation, we'll just do idle for now. We're going to change this to self.assets, and then we're just going to give the player, because we don't need to give the player other assets like tiles and images and the enemies images. We just need to give it the player's image, or the images. So right now we're just going to give it all of these inside here, and right now we've just got idle. So we'll go into player. Now that we've got frames, we can say frames is just a list of images, but we want to say the player image is going to be one of those images. So right now let's just say self.image is equal to frames, and it's going to be idle because we're getting the idle animation, and we're going to get the first frame from the idle animation. And when we run this, oh, I know where the error is now. So we're saying self.assets and we're getting the player, but we don't know what assets is because this isn't being called. So let's, before we even make the groups, let's just say self.loadAssets. And there we go. The players is now back to the same image as before. So in our entity class, let's make a animation with our argument of delta time, and in here we will update our index or add a number to our index. So self.index plus equals animation speed multiplied by delta time. So delta time is how much time has been passed from one frame to another. Now if you've got a really fast computer, it's going to be 0.001 or something like that, but if you've got a slow computer, if you're running at like 1 frame a second, it's going to be 1. And the point of delta time is to make everything seem smooth. Even if you're running at 500 frames per second, it would try to be as smooth as possible, and the same as if you're on a really slow computer. So the way we're going to actually use delta time is by, in here, we're setting delta time to 0. Now when we try and animate, it's always going to stay on the first frame because it can't add to the index. So let's just say delta time is equal to, actually we haven't even got a clock, so we can't even check the time. So self.clock equals pg.time.clock, and then every time we update, we need to first self.clock.tick. So tick is how many frames per second there are, but if you're not going to, if you're going to have infinite amount of frames, like how much frames your computer can run, you just put 0. But if you want to be a nice steady frame rate, I like 120. And then to make it delta time, you need to divide it by 1000. And then instead of 0, it's going to be delta time. Back to the entity class. When we do the animations, we need to check if the index is greater than or equal to the length of self.frames and self.status. So we're getting the dictionary, and the key in the dictionary is this, as you see. Idle is the same as idle here, but this is always going to change. So when you're moving, the status is going to change to move or walk or run, and when you're not moving, it's always going to stay the same to idle. So when we've reached the highest point of this list, so remember, this is going to be a list, this returns self.frames and self.status. When we reach the end of the list, just set index back to 0. And then what we're going to do, instead of updating it all the time in the update, so setting the image back to this, every time we finish animation, we say the image is equal to self.frames, self.status, and because when we multiply by delta time, it's going to be a floating point number, you can't get a floating point number in a index, in a list. So you do int self.index. So now, I know this has been quite a bit of code here and quite complicated, but just make sure, if you want to go back on it, there is a GitHub repository of all of this code, still from the same. So as we do player, we will overwrite the update function. So because we're, and delta time. So in entities, because we're inheriting from sprite, it's got a built-in function called update. And whenever we update the group, we're updating all of the sprites in that group. So if we've got an update whatever's this class has got. So when we update, we want to just say self.animation and delta time. So hopefully, cross fingers that this works. And there we go. A nice simple bob up and down animation. And you've got delta time, so a nice steady frame rate. And we've also got status, a new entity function to use other enemies with and the player itself, and maybe tiles, or we might get another separate class for that. But you can also add other functions to the entity class, and the player is also able to access it. As you see, self.animation, it's not in this class here, but it's in the inherited class. So let's say delta, this speed is a bit slow, so let's go 12. It's a little bit faster. You can also say, we're going to copy this and say we don't want the idle, we want run. So we get run here, and run is just this. So copy this and replace idle with run. Run that, and look, now he's running. So it's really simple. All you'll need to know is you're loading images into memory. Remember, you've got RAM. This is loading the images into your RAM. And then this here is updating or setting your image to whatever image you give it here. And right now we're changing the image every single frame. We're checking, and then we're checking, and then boom, we're changed it. And that's why it looks like it's moving, but it's not. It's just an image changing every couple of seconds or every couple of milliseconds. So this is going to be the end of today's video. Tomorrow we are going to be doing some player movements, some more functions inside the player, and because we've done all of this hard work at the start, it's going to be a little bit, or should I say it's much more easier later on. So thank you guys all for watching. Make sure to watch episode 1 and 2 so you can get a greater understanding of how all of this works, because I started all from the beginning, even downloading the images itself. Thank you guys all for watching. Please like and subscribe, and I'll see you later.